For more than a decade now, I've been using Pusher, formerly Pusher app, to implement my WebSocket workflows in my ColdFusion and Lucee CFML applications, and I absolutely love Pusher. But one issue that our ColdFusion applications have always suffered from is dealing with loopback events, or essentially the WebSocket events pushed back to the same client that initiated the operation that originally triggered the WebSocket event in the first place. This usually leads to unnecessary data loads at best, and at worst can lead to some janky UI experiences where there's some DOM thrashing and re-rendering of data and weird timing. But now that I've embraced the request scope within ColdFusion applications and got rid of my dogmatic aversion to it, I think it's going to open up some really simple solutions for these loopback events. So to demonstrate, I have a simple demo here that listens for clicks, and when I click here, it's going to make an API call back to the server. Imagine this was some sort of state mutation on the data persistence layer. That API call is going to get pushed to Pusher, which is then going to emit a WebSocket event down to all the subscribed clients. But at the same time, I'm also incrementing this counter locally in an optimistic fashion so that the user doesn't actually have to wait or depend on that WebSocket lifecycle to manage the counter, right? Because that would lead to some janky delays. But what you'll notice is that every time I click, it increments by 2. And that's because when I click, I'm both incrementing the counter locally, then later on, listening for the WebSocket event, responding to the WebSocket event, and incrementing the counter again, even though I'm the browser that initiated that request in the first place. So to fix this problem, let's go into the code. What I'm going to do is in my click handler, where you can see I'm incrementing the counter locally in an optimistic way and then making the AJAX call, I'm going to be including a browser UUID, UUID standing for Universally Unique ID. I'm going to include that in my HTTP headers. I'm then going to take that UUID and propagate it through to my Pusher API call such that the browser UUID is then emitted back with the WebSocket event to all clients, and I'm going to use that UUID to ignore events that my browser initiated. So I actually have some code commented out, but if we jump up here, and let's just comment this back in, and let's refresh. What you'll see is when I click now, I still get that API call and I still get a WebSocket event, but the counter is only going up by 1 at a time. And that's because we're ignoring the UUID if it matches the UUID of our browser, right? So if we look at our event on the WebSocket channel here, this Pusher WebSocket channel, I have my event data that comes through. I'm looking to see if the browser UUID in that WebSocket payload matches the browser UUID that I have locally. And if so, I'm going to short circuit out of this event handler, thereby ignoring the event. Otherwise, I'm going to increment my counter locally. Now, when we only have one browser, we can't really see that, but let's pull in a second browser here. Let's just refresh. Pull in this browser. Let's refresh here as well. So now we have 2 different browsers, each with their own universally unique ID, their own UUID. And you'll notice that when I click in one, this browser says that it's ignoring its loopback event, but this browser is receiving that event. The browser UUID is different, so it's going to accept it. Of course, if I click into this one, you'll see that now this one's ignoring that loopback event, but this one's accepting it. And we're able to keep these 2 browsers in sync by ignoring our local events, but accepting our non-local events. Now, I talked at the top of the video about how I'm enabling this by finally embracing the request scope of ColdFusion. Request scope is a globally available scope within the request of the ColdFusion application, which means it's available in the components, it's available in the templates. You don't have to pass it around. It's just globally available in the same way that the URL, the form, the cookie, the CGI, the server scope, those are all globally accessible. The difference is that the request scope is scoped to the request itself, meaning that every request coming into the ColdFusion application gets its own copy of it. So let's take a quick look at how this is going to work. So again, on our click handler for the DOM event, we're going to increment the counter locally and make our API call. We're going to include that browser UUID. Now let's jump up into our ColdFusion application component. Our ColdFusion application component handles all the incoming requests. It sets up the settings. It defines the event handlers. We're going to use our onRequestStart to add some logic at the top of every single request coming into the ColdFusion application. Here, I'm going to get the HTTP request data and grab the headers. I'm going to look for that browser UUID header that I added in the AJAX request, and I'm going to push that into the request scope. This browser UUID is now globally available to every piece of code that has to be involved with the processing of this request, which means that way, way deep down in my call stack somewhere, even without having to pass anything down through the methods in the call stack, I'll be able to reference this value. And that's exactly what I'm going to do in my API call. Now, in my API call, there's no call stack here, but just imagine that this was deep down, passed through workflow layers, packed through service layers, down to a sort of an infrastructure layer where now I'm responding to domain events within my ColdFusion application, and I have to publish this to Pusher so that Pusher can then publish it over the WebSockets. And here, I'm reaching into that globally available request scope, grabbing that browser UUID, and I'm going to include that in the WebSocket event data that I'm pushing to Pusher, which Pusher then, as we saw in the browser, is happily echoing it back to all of the subscribed clients. And you'll see, let's clear this one more time. You will see that the same UUID, although it's a little hard to see in this getting cut off here, but you can see BBA9106B6, BBA910B6, right? It's the same UUID being passed down to each of the browsers. And of course, if this one were to trigger the event, we'll see it's different. So this one's BBA9, this one's DF29, which is why the IDs are either being accepted or rejected in the different browsers. So anyway, I've been using WebSockets and Pusher for 10 years, and I've had this loopback problem forever. But now that I'm feeling comfortable in using the request scope to manage these sort of magical data propagation elements within my ColdFusion application, I think this is finally going to make a really, really simple solution to this problem that I've had for a long time. And what I love about this is how easy it's going to be to layer this into my legacy brownfield ColdFusion applications, because all the code that you're seeing in this demo is basically the code that I need to add to my existing applications. Using HTTP interceptors in my Angular apps, I can easily add this. Then in my ColdFusion request processing, I can easily add this at the top of every single request. And then at the very low level Pusher interaction in my real-time service layer, I can easily augment all of my WebSocket events with this browser UUID. So it's just gonna, I haven't done it yet, but I'm imagining this is just going to work. So it's super, super exciting. And I think it's really going to add a subtle improvement, but meaningful improvement to my ColdFusion and Angular applications.